Okay, let's start. Yesterday we were talking about the color of complexes. Color in coordination compounds. So there were two reasons. There are two main reasons for color in coordination compounds. One was DD transition. Okay, so we talked about DD transition yesterday. And the second reason for the color is charge transfer. Okay, charge transfer or electron transfer. Now in compounds like potassium permanganate and potassium manganate, potassium dichromate, these compounds in dichromate, right? These compounds are colored because of charge transfer concept. Potassium permanganate, manganate, dichromate. Now what happens here is, like suppose you have manganate ion, MnO4, 1 negative. So manganese क्या करता है? It forms 4 bonds. It forms 4 bonds. It forms 7 bonds with the oxygen atom. ठीक है? 4 oxygen atom के साथ इस तरह से bonded है. अब यहाँ पर oxygen has a negative charge. So there is this transfer of electron from here to here. So oxygen क्या कर रहा है? Because it is participating in resonance, electron shifting takes place, and because of that electron transfer, some energy is absorbed and some is released. Like there is bond formation. So during bond formation, some energy will be. During bond formation, some energy is released. Okay. So likewise, जब यहाँ से ये bond shift हो रहा है, तो some energy will be used up. So during this electron transfer, some energy is absorbed. So during electron transfer, some energy, some part of the visible range, some energy is absorbed and rest is emitted. Okay, some energy is absorbed and some is released. So this is responsible for the color in case of such complexes. Because if you see the oxidation state, manganese shows +7 state, and manganese +7, if you see the oxidation state, manganese is in +7 state. So in +7 state, see manganese क्या configuration show करता है? 3d5 4s2. So +7 would mean 3s to 3p6, right? Meaning no electrons in d orbital. So manganese +7 state means no electrons in d orbital. So we can't explain it in terms of dd transition. ठीक है? So अभी dd transition की terms पे explain नहीं कर सकते, तो इसको कैसे explain करेंगे? Charge transfer की concept की terms में. इलेक्ट्रॉन की ट्रांसफर की वजह से कुछ एनर्जी एब्सॉर्ब हो रहा है, कुछ रिलीज हो रहा है, and that is responsible for the color of these complexes. ठीक है? Which gives color to these complexes. So that is responsible for the color of these complexes. Okay. Likewise, you have this complex So another example of charge transfer or electron transfer is the brown ring complex. So what is the brown ring complex? Penta aqua, nitrosonium, iron, 1 sulfate. Okay. Here NO is present in NO1 positive, iron oxidation status 1. So what is this brown ring complex? It is penta aqua nitrosonium, penta aqua, because 5 water are there, so penta aqua, nitrosonium, iron, oxidation state 1, then space, and then the counter ion sulfate. Penta aqua, nitrosonium, iron 1, sulfate. This is your brown ring complex. Okay? It is also colored because of the charge transfer or electron transfer. अब यहाँ पर क्या होता है? If you look at the oxidation state of iron, iron initially is present during the brown ring test. If you remember the brown ring test for nitrates, so here the iron is present in +2 state. And we have nitrosonium ion formed in the first step. NO is formed. तो क्या होता है? NO अपना इलेक्ट्रॉन ट्रांसफर करता है. There is a transfer of electron from NO to Fe2 positive. ठीक है? So here also there is transfer of electron from NO to Fe2 positive, and due to transfer क्या होगा? NO converts into NO1 positive and ferrous converts into Fe1 positive. So earlier, if you see the reaction, so iron is present in +2 state in the complex, and NO is present. NO is formed during the reaction. Okay? Nitrate gets reduced to NO. So then this NO transfers electron to ferrous, and because of this electron transfer, NO gets converted to NO positive, ferrous converts into Fe2 positive, converts into Fe1 positive. So this electron transfer takes place, and this is responsible for the color. Okay? This electron transfer is responsible for the color. So now Fe1 positive, iron is in +1 state. तो configuration क्या होगा? Iron is 3d6 4s2. ठीक है? +1 would mean 3d6 4s1. Now remember, जब भी हम कोई भी overlapping या hybridization करते हैं, तो s orbitals should be vacant. Because coordination number 6 है, तो coordination number 6 में हमारे पास 2 hybridization के cases आते हैं. One is sp3d2 or d2sp3, either of the two. And in both the cases, s orbitals are required, so they should be vacant. So we transfer one electron from s to d. So the configuration we will take is 3d7, right? And water कैसा है? It's a weak ligand. See, iron +1 state में है, so +1 is a low oxidation state, and water is a weak ligand. ठीक है? Iron is in +1 state, low oxidation state जब होता है, तो again the interaction is poor, there will be less splitting, and water is a weak ligand. Again, these two factors contribute to less lambda. So crystal field splitting कैसा होगा? कम. ठीक है? So ferrous का iron का oxidation state कम है, water is a weak ligand, and because of this there will be less splitting, so lambda will be less. Now when splitting is less, what happens? Splitting जब कम होता है तो pairing नहीं होता, right? जब splitting ज़्यादा होता है, then only the pairing takes place. So there will be no pairing, so the outer d orbitals will be used. So what will be the hybridization of this complex? sp3d2. And if you look at the number of unpaired electrons, this question was asked in the previous years. Okay? Question on brown ring complex. They will not mention the formula. They will just write down brown ring complex thing, and they'll ask you anything about the brown ring complex. Oxidation state of iron is asked, right? And they'll ask you the formula or maybe the IUPAC name, number of unpaired electrons. So 3D पे कितना है? 7 electrons. So 1, 2, 3, 4, 5, 6, 7. 3D 7 configuration है iron का. So how many unpaired electrons? 3. So you can find the magnetic moment. N into n plus 2. So that is root 15 Bohr magnetons. Just go through. question asked from here. Brown ring complex. So because we have unpaired electrons, the complex will show paramagnetic character. ठीक है. So first you should know the name of the brown ring complex. ये brown ring complex कहाँ बनता है? नाइट्रेट आयंस के डिटेक्शन में. जब हम नाइट्रेट आयंस का डिटेक्शन करते हैं in the presence of ferrous sulfate, then we get this brown ring complex, right? So they'll ask you questions on brown ring complex, maybe IUPAC name, iron का oxidation state, it is colored due to charge transfer or electron transfer, that you should remember. Then maybe hybridization, paramagnetic or diamagnetic, magnetic moment, number of unpaired electrons. So these are the questions usually asked. Now another important compound that is usually asked is sodium nitroprusside. Another important compound complex that is formed in the detection of sulfide ion. So in organic chemistry, when we detect the sulfide ion, so क्या करते हैं? Sodium nitroprusside is added. Here again, NO is NO1 positive. ठीक है? What is this complex? The common name for the complex is sodium nitroprusside, and it is used for the detection of sulfide ion. Sodium nitroprusside को जब sulfide ions में sulfide containing solution में डालते हैं, तो it converts into a sodium thionitroprusside. So violet colored complex is formed with sulfur. So detection of sulfide ions के लिए sulfur in the organic compound, detection of sulfur में इसको use करता है. Okay, now what will be the IUPAC name? The IUPAC name is sodium. This one is the common name. Sodium pentacyanito nitrosonium ferrate and the oxidation state. So what is the IUPAC name of sodium nitroprusside? It is sodium pentacyanito nitrosonium ferrate 2. It's a purple color complex. Again, let's see iron का oxidation state क्या है? Earlier iron was +3 state and NO was formed, right? So यहाँ पर भी NO transfers electron and converts into NO1 positive. जो NO present होता है solution में, वो क्या करता है? Electron transfer करता है ferric ions को. So खुद convert हो गया NO1 positive में, और ferric ions जब electron gain करेंगे, they will convert into ferrous ions, right? So because it is giving electron, it requires a positive charge. They are gaining electrons, so the ferric is reduced to ferrous. Okay, so again transfer of electron takes place. So this is the reason why it is colored. So it is a purple colored complex, and the reason for color is again charge transfer, right? And now if you look at the ligands, iron is present in +2 state. +2 means 3d6 configuration. And Cn क्या है? Cn negative is a strong ligand. तो strong ligand की presence में lambda कैसा होता है? High. अब splitting जब ज़्यादा होगा, तो in that case pairing takes place, meaning the inner d orbitals will be involved. So 3d6 configuration है. So either you can make it like this, or you can directly show. So when you have 3d6 configuration, and that means this lambda is large, lambda is more. So if lambda is more, what we will do? We will pair up. So 6 electrons will pair up here only. ठीक है? नीचे वाला जो T2G सेट है, उसी में इलेक्ट्रॉन्स का पेयरिंग हो जाएगा. तो EG सेट खाली है. 2 orbitals are vacant. So these 2 orbitals will be used for hybridization. So inner 2d orbitals will be used for hybridization. So hybridization will be D2sp3. And as we can see, all electrons have paired up, no unpaired electrons. So the complex will be diamagnetic. Right? So on the basis of the ligand and iron oxidation state, the complex is obviously octahedral complex है, coordination number 6 है, hybridization D2sp3. Inner d orbitals are involved, so we can call it as inner orbital complex. Whenever inner d orbitals are involved, we call it as inner orbital complex. ठीक है, octahedral inner orbital complex, color due to charge transfer, diamagnetic. So they will just give you sodium nitroprusside. Okay, they will not mention the IUPAC name, they will not give you the formula. Sometimes they will just mention the name, the common name of the complex, sodium nitroprusside, and they can ask you anything. They can ask you the oxidation state of central atom, coordination number, geometry, hybridization, paramagnetic or diamagnetic, or they may ask you the reason for the color of complex. Right? So these are the questions usually asked. So just remember, there are two reasons for the color of coordination complexes. One is the DD transitions. For DD transitions, ligands should be present and there should be unpaired electrons. And second is charge transfer. Let's go through. Okay, now. So next we will start with metal carbonyls. Another type of complexes that in which carbonyl is the ligand, okay, are called as metal carbonyls. So as the name suggests, ये जो complexes है यहाँ पर carbonyl is acting as the ligand. So what is the ligand? CO. So what are metal carbonyls? The complexes in which CO acts as the ligand. Now these are further divided into two categories. Homoleptic, हमने पहले भी पढ़ा है, homoleptic, heteroleptic. What is the difference between homoleptic and heteroleptic? Homo means same. What is same? The ligand is same, right? For example, we have NiCO4. So all the ligands are of same type. मतलब CO is acting as a ligand. So homoleptic में क्या होता है? Only CO is acting as the ligand. So homoleptic metal carbonyls क्या होंगे? Only CO is present as the ligand. Only CO is present as ligand. ठीक है? Only carbonyl is acting as the ligand. And hetero means different. So other than CO, some other ligands may be there. ठीक है? जैसे maybe CO4 है, Cl2 है. So when some other ligands are present, other than CO. So when some other ligands are present, other than carbonyl, we call it as heteroleptic complex. ठीक है? So other ligands are also present with CO. अच्छा, नेक्स्ट इंपॉर्टेंट पॉइंट क्या आ जाता है? होमोलेप्टिक, हेटेरोलेप्टिक हम जनरली भी यूज करते हैं कम्प्लेक्सेस के लिए. कोई भी कम्प्लेक्स होमोलेप्टिक उसको बोल सकते हैं अगर सेम टाइप ऑफ लिगेंड है. ठीक है? एंड हेटेरो इफ द लिगेंड्स आर डिफरेंट. देन रिमेंबर, जितने भी मेटल कार्बोनिल्स होते हैं दे फॉलो द इफेक्टिव एटॉमिक नंबर रूल गिवन बाय सिल्वेक. So what was that? We'll quickly review. 18 electron rule or the effective atomic number rule. Most of the metal carbonyls most of the metal carbonyls follow EAN, that is effective atomic number rule, or 18 electron rule. ठीक है. So 18 electron rule is almost similar, बस यहाँ पर हम valence shell electrons लेते हैं. When we take the 18 electron rule, we just talk about the valence electrons of the metal ion. And when we talk about effective atomic number, then we take the atomic number of the metal ion. So we will see both of them. Suppose you have a complex NiCO4. इसमें हमने effective atomic number rule लगाना है. तो कैसे लगाते हैं? First we will see the atomic number of central atom. Atomic number of central atom minus the oxidation state of the central atom. Then we add the number of electrons gained from the ligands. Number of electrons contributed by ligands. Number of electrons contributed by ligands. So quickly find out the effective atomic number of nickel tetracarbonyl. So what do you think? What is the effective atomic number of nickel in tetracarbonyl nickel?